So how do we explain a physical phenomena for spin nuclei that are not 1/2? Well, let's go back to our spinning top analogy. So a spin 1/2 nucleus, we have one rotation axis acting on our electron. So it can be stable both in the up, ooh, man, that's hard to turn, and down positions. Now, let's say we took this gyroscope and on the ends, so we got two edges here, we hooked this to a string and we began to spin it around on this axis. So we actually will have it spinning along the z-axis as well as the x-axis. Well, this is where you start kind of getting this effect of what are called non-spin 1/2 nuclei or non-dipolar nuclei. So there's actually two spinning, it looks like there's two spinning axes, and because of that we have different combinations in terms of clockwise and counterclockwise for the way these two axes can be spinning relative to each other. So we end up with actually getting multiple stable directions in terms of spinning clockwise and counterclockwise. So not only do we have to consider the spinning along the z-axis in this case, we can consider the spinning along the x-axis or y-axis as well relative to the magnetic field. So when we have nuclei that are not spin 1/2, what we mean is that there's more than a clockwise and counterclockwise solution to what is stable in the magnetic field. We actually end up producing more. And this is actually a fun historical fact. This is where the spin numbers come from. Is the number of stable spinning states is 2s plus 1, 2 times the spin plus 1. So if we have a spin 1/2 nuclei within a magnetic field, 2 times 1/2 plus 1, there are two stable orientations relative to the magnetic field. In this case, clockwise and counterclockwise. If we have a spin of 3/2, it ends up being 4 stable states. So the best way to think about non-dipolar or non-spin 1/2 nuclei is that you actually have multiple axes along which there is angular momentum, there is rotation. Now, is this a perfect analogy? No, there are definitely issues with the angular momentum analogy, but hopefully they make it a little bit easier to see why you have two or more possible solutions, and this is why you start ending up, getting these different types of answers for NMR.